All right, so we're going to take a look at section 4.2. We're going to split it into two parts. We'll do half today and then half tomorrow. And this section focuses on the law of sines. So a couple weeks ago, we did the same thing. We solved triangles, found out how big the angles were, how big the sides were, except we always had a 90-degree angle. And this week, we're going to do the same basic thing, except none of the angles will be 90. If you have a triangle where none of the angles are a right angle, that's called an oblique triangle. Oblique. And there's two main types of an oblique triangle. Anybody know one type of triangle you can have where none of the angles in it would be 90? Well, scalene just means that they're all different. So you could have like a 30, 60, 90. That's a scalene triangle, but it does have a 90. Sure, an acute triangle. Okay, so if you had all your angles less than 90, an example of that's an equilateral. They're all 60. Okay, but any triangle where they're all less than 90, yeah. And an obtuse. Okay, in an obtuse triangle, you have one angle that's bigger than 90. Can you have more than one angle bigger than 90? No. Because the angles have to add up to what? 180. And if you had two angles, both bigger than 90, that would be more than 180. Right, so next we're going to look at our diagram. Okay, how do we set up these types of problems? What did we use for the names of the sides a couple weeks ago?
A, B, C.
Yeah, and we're still going to use A, B, and C. And what angle was always across from side A? Alpha. And how about across from side B? Beta. And the only difference now is across from side C, we always had a right angle. Well, now it's not a right angle, so we got to give it a name. Okay, so we still have A, B, and C. Still have A across from alpha, B across from beta. And we have a new Greek letter to represent the angle across from side C that used to be the right angle. Anybody know the name of that Greek letter?
Gamma.
That's gamma.
What's it called?
Gamma. G-A-M-M-A. Gamma. Kind of looks like a V with this top part's a little bit curved.
Seagull.
Yep. Kind of like a bird like that.
There's a new very long so
And to solve these kind of triangles, you've got to start off with three pieces of information. A couple weeks ago, I gave you the 90 in every problem, so that was one piece. And then I could either give you two sides, or I could give you the 90 and give you a side and an angle. Okay, but the point is you've got to have three things. So the first case I could give you would be two angles and a side. And there's a couple ways I can do that. I can either give it to you as angle, side, angle. The order of the letters here is just indicating the placement of the angles and the sides in the triangle. So I'll show you a picture. But in the first case, the side that I would give you would be the one that connects or is between the two angles I give you. In the second case, the side that I give you would not be between the two angles. And here's a picture. Okay, on the one on the left, you've got two angles, and the side that you know is the one that is connecting the two. The side is between. The one on the right, here you've got two angles, and the side that you know is not between the two angles. Okay. And the one on the right, whether you know that side or that side, it would be the same type. If I gave you the bottom side, then it would be the other type, because the side would be the one that's connecting the two angles. Any question on those two types? Okay, so 2 angles on a side, or we could switch that. I'll give you 2 sides and an angle. There's a couple ways you can do 2 sides and an angle. This is one of them. Side, side, angle. Preferably in that order, not the other way. It's just more polite, you know. And there's an example of side, side angle. You got 2 sides, and the angle that you know is not between the 2 sides. What would it be if the angle was between the 2 sides? What type would that be? Side, angle, side. That's a different type that we're not going to do with this law. Law of sines can't be used on side, angle, side. And there's one other arrangement of letters. Anybody know the last way you can arrange? Angle, so angle, angle, side would be side, angle, angle. Yeah, same thing.
Wait, so side angle side isn't one?
Yep, side, angle, side is not one that we can do with what I'm teaching you today.
Okay.
It is one, but we're not doing it today. And there's one more that we can't do today either.
Angle side. Side, side, side.
Yeah, side, side, side. We can do it, we just can't do it with what we're learning today. All right, so the only 3 that we can do are angle, side, angle, angle, side, side, angle. Those are the 3 that fall under law of sines. Anybody know the other law? We're going to learn this on Wednesday. But there's a law of sines and there's a law of cosines. Law of cosines would be used for side, angle, side, and side, side, side. And when you start to learn the law of cosines, you'll see that it actually kind of looks like the Pythagorean theorem. And it kind of is, a little bit. Okay, so one of the first things you want to do when you start one of these problems is figure out, is it one of the 3 types that falls under law of sines? If it is, you use that law. If it's not, you're going to have to use a different law, which you're not going to learn until Wednesday. All right, so next what we're going to do is we're going to take a look at where the law of sines comes from. Okay, we're not going to go through the entire explanation of it, okay, but we will look at part of it, and I think once we look at part of it, you'll see a pattern, and you'll be able to get the next part of it. All right. So what we've got here is a triangle. Okay, for now you can just draw that. And I'm not labeling side C or gamma because I don't need it. I'm not going to use it. What I do want to do is draw in the height. Okay, by drawing in the height of the triangle, it splits this big triangle into how many? 2. And what kind of triangles did I just split? They're special triangles. Yeah, they're right triangles. Now we've taken this problem and split it into 2 right triangle problems. What we're going to do is we're going to focus on the left triangle first, and then we'll focus on the right triangle. Okay, so what I'm going to do now is I'm just going to cover up the right-hand side. Okay, what do you call this vertical line in the triangle? It's the what of the triangle? Yep, it's a leg, and specifically it's measuring the height. Yeah, it's the height. So let's just label it H. Right, and if that angle on the right's a 90, then so is the one on the left. So what I want to do is use a trig function, either sine, cosine, or tangent, that will involve H and B. Okay, so just like what we've done before. So I got to figure out the names of these sides relative to that angle. What's the name of H relative to alpha? Yeah, opposite. Good. Okay, what's the name of B? It's hypotenuse, yeah, because it's across from the 90. So which trig function has opposite and hypotenuse in it? Tangent, opposite, and adjacent. Sine, yeah. Sine. Okay, so the sine of my angle equals, what's the side opposite? That was, what was it again? H divided by opposite over hypotenuse, which is B. Okay, next I want to solve this for H. I want to get H by itself. Okay, Ryan, how would I get H by itself?
If you multiply it by the reciprocal,
Well, if you multiply by the reciprocal, that would be B over H,
yeah.
and then you're going to end up with an H in the denominator. So we've got an H in the numerator, that's okay. I just don't want the B there.
Is it that B?
Yeah, just multiply it by B and by B. Okay, what that does is it gets H by itself, and now we have B times the sine of alpha equals the height. We have a formula for the height. Any questions on how we got that? All right, so now we're going to do the exact same thing on the right side. Okay, we'll come back to that formula in a minute. All right, so again, I want to set up another trig equation involving the two sides that I know, H and A. Okay, what's the name of H this time relative to beta? It's still opposite. And what about the yeah, good job. The hypotenuse is A. Okay, so set up your trig equation just like before. Sine of my angle is opposite over hypotenuse. And I want to get H by itself again. How would I get H alone? Yeah?
Times it by A.
Good job. Times it by A. Times it by A. So now I have another formula for H, different than the first one. A sine beta equals H. And B sine alpha also equals H. Okay, two different ways to find the height. What do you know about the two things that I put in boxes? If they're both equal to H,
They're both the same.
they're both equal to each other. Okay? What's in, we'll call that box 1 and box 2. Box 1 equals box 2. Why? Because they're both equal to H. So that's my next step. And my second to last step. So B sine alpha is going to be exactly the same as A sine beta. Okay, and my last step is kind of a trick to make this equation look like the law of sines. We're going to divide each side by A times B. We're going to divide by A times B. Now normally when you divide by a letter, you have to be careful, because if that letter could be 0, we just did something we're not allowed to do. We divided by 0. But I guarantee you A and B can't be 0, because they're sides in a triangle. You can't have a side with a length of 0. So now let's look at what happens. What's going to happen on the fraction on the left?
B.
The b's are going to cancel out. And you're left with sine of alpha over A. What about in the fraction on the right? The A cancels. And you're left with sine of beta over B. These are the first two parts of the law of sines. Sine of alpha over A equals sine of beta over B. Does anybody have a guess what the third part will be? Following the pattern we have here?
Kind of gamma.
Yep.
C.
Sine of gamma over C. Very good. So this is the law of sines. Now we didn't prove this last part. We only proved the first two. But you could do the exact same proof we just did again. We're not going to go through it, But instead of drawing the height from the top, draw the height from some other vertex. And that's how you do it again. Okay, so that's your law of sines. Okay, when you use this law, I think it has three parts. That's how I look at it. The first, the second, and the third fraction. You never use all three parts at the same time. Only two at a time. So you're either going to use the first part and the second, or the second part and the third, or the first part and the last part. But we'll never be using all three parts at the same time. And does anybody remember what that's called? When you have something that's set up like this, a fraction equal to another fraction? Like if you had something a little bit more simple, let's say, that's a proportion. Right? And the way that you solve a proportion from Algebra 1 is exactly the same way you're going to solve it here. Does anyone remember the name of? You cross multiply. Okay, so that's all the law of sines is. It's a lot of cross multiplying. Okay. Okay, so this is a tip that we've already done this before, but when you're solving a triangle, we'll make a sketch to visualize it. And then we'll organize all the data in a table. Now, we don't have a 90-degree angle anymore. So what theorem are you not allowed to use if you don't have a 90-degree angle? Yeah, you can't use the Pythagorean theorem because you don't have a hypotenuse anymore. To have a hypotenuse, you have to have a right angle. But there is still a fact that we can use that it's still true. What's another fact about triangles that's always true?
They add up to 180
What does?
degrees.
What adds up to 180 degrees? Yeah, all your angles still add up to 180. That fact is still true. Okay, so that's kind of the setup of what we're going to do and the law that we're going to use. And what we'll do is we'll try to do one of each type of the three types. Okay, any questions on kind of the basic idea of what we're going to do? All right, so let's take a look at what our first problem. Okay, so the first problem, I've already set up the table for you. Okay, I just told you that alpha is 40, beta is 60, and A is 4. Okay, one hint that you know you're going to use the law of sines is you have a row, not a column, a row in the table that's got everything in it. If you've got a row with everything in it, that's a hint that you're going to use the law of sines. Why? Well, if you've got a row that has everything, then you have the top and the bottom of a fraction in the law. Okay? So you've got alpha, you've got A, you've got everything in this first part of the law of sines. So that first row is going to be very important to find B and to find C. Okay, but before we find B or C, let's find the other angle. That can be done relatively easily without too much work. Yep, how do you know it's 80?
60 is 40 is 100 and that's 180.
Right. Now, that is something that we calculated. What did I say a couple weeks ago about using things you calculated?
That was wrong, so don't use it.
Yeah, don't use it. Okay, so a couple weeks ago we were able to do that. This week we can't. Okay, we're going to have to calculate things ourselves, and we're going to have to use them to find other things. That's just the way this law works. So in this case, you have to use gamma to find C. You don't have a choice. So if you made a mistake finding gamma, what does that mean about C? C is automatically wrong. Now you could still get B right. B is not going to be affected by C or gamma. Okay, but let's go through it and let's set it up. Okay, so first thing I'm going to do is I'm definitely going to use the top row. Why? Because it's complete and both things were given. Okay, so let's start by looking at the part that has alpha and A. So sine of alpha divided by A. So in this case, sine of 40 divided by 4 equals, and now I can pick B or C. Okay, let's do B. So let's write down, we're going to solve for B. If you're going to solve for B, you have to pick the part of the law that has B in it. That's the second part. So now we're going to write sine of beta divided by B. So in this case, sine of 60 over B. Every time you set up a law of sines problem, there should only be one letter in it. Okay? In the left-hand fraction, we have a number. In the right-hand fraction, number in the top. We have one letter in the bottom. Okay. And how do you solve a proportion? You cross multiply. 4 times the sine of 60, which I'm not even going to do that out. I don't care what that is right now. And what's going to be the other product? B times the sine of 40. And how do we get B by itself? Yep, how do you get sine 40 on the other side? Yep, divide by the sine of 40. Okay, all you did here was you took B and you multiplied it by a number. If you want to undo multiplying, you divide. And divide. So these cancel out. And you're left with B equals. And now I want to find out what that is.
You just type it in, retype it.
We type it in. Okay, we just have to round it. We'll generally round to three decimal places. Okay, first thing you want to do is make sure you're in degrees. And you're in degrees all week. Okay, so if you're in radians, switch to degrees. Okay, on my calculator, I pretty much can type it in exactly in the order I see it. 4 times the sine of 60 divided by sine of 40. Notice how I close my parentheses? I'll type it in a minute, and I won't close them, and I'll show you what happens. So you get 5.389. Now, if you have to type it in multiple steps, that's okay too. You could do 4 times the sine of 60 first. Get the answer, but don't round it. Just leave it. And then take and divide that answer by sine 40. And I get 5.389. Let me show you what happens if you type it in all at once and you forget to close a parenthesis. Don't think the calculator is going to handle the order of operations correctly. No. Okay, what the calculator did there, let me show you what it did. It did 4 sine of 60 divided by sine of 40. That's what it just typed in. Okay, because you forgot that extra parenthesis, so it put everything inside the argument to the first sine function. Okay, so make sure you type it in, close your parenthesis. And that's B, 5.389. Okay, now we have 2 rows that are complete. Okay, both rows have everything in them. So I could pick either one to find C. Which row would be better to pick?
A,
Yeah. Why is A better?
because they gave you it.
Yeah, they gave us it. Okay. We're still going to have to use something we calculated, but at least we're using some stuff that was given. Plus, nothing is rounded off in row A. Those are all exact answers. So sine of 40 over 4. It's going to start the same way. Equals. And what's going to be my fraction on the other side? So we have sine of 40 over 4. Sine of gamma over c, and we'll fill in what we know. Gamma is 80, so sine of 80 over c. Now we're using the first part and the third part of the law of sines. Okay, and let me show you a shortcut for doing the cross multiplying. C is going to be 4 sine 80 divided by sine 40. Okay, if you did that out and showed everything, you'd have 4 sine 80 equals c sine 40. But then you'd have to divide each side by sine 40. Any questions on how I got C? Doing the cross multiplication in my head? Everyone's okay? All right, so that's probably the way I'll do it from now on, just to save us from having to write out this step in the middle. Okay, so now we've got C. Type that in. Okay, so we're going to take 4 sine 80 divided by sine 40. Now, before I even hit enter, let me go back and look at my angles. Gamma was the biggest angle, so C should be the biggest side. Your biggest angle should always go with the biggest side. Smallest angle, smallest side. So I know that this side has to be bigger than 5.389. Has to. Okay, so let's hit enter. And we get 6.128. Okay, so there's a couple quick things you can do to figure out if you think you're in the right ballpark and your answers are pretty good. Check and make sure smallest angle is with the smallest side, biggest angle is with the biggest side. The next quick thing you can check, if you don't have time to redo the whole problem, if you add up any two sides of a triangle, they have to be bigger than the third side. So like if I add A and B, I get 9.3 roughly. That's bigger than C. If I add B and C together, that's bigger than A. If I add A and C together, I get 10.128. That's bigger than B. That's a relationship that's true in any triangle. Two sides added together is always bigger than the third. If that didn't work, then that's just something's telling you it's not right. Okay, something's wrong. All right, but those are a couple things I usually check just to quickly see if I made a really obvious mistake. If I made like a rounding mistake, that's not going to find that error. Okay. But that's it. That's a law of sines problem. Any questions on that? Right, so that was the type where you have two angles and a side. Okay? We actually didn't make our sketch, but on the test it would be a good idea just to make sure it's not law of cosines. If that's A, that would be alpha. That's B, and that's beta. This is angle, angle, side. That's the type we just did. Okay, let's look at the next thing. This one is not angle, angle, side. Okay, what type is this one? This is angle, side, angle. This time the side that you know connects the two angles. Okay, earlier I said to use the law of sines, you have to have a row with everything in it. Do we have a row with everything in it?
No.
No. But can I find a row or find something and then I'll have a row with everything in it?
Oh, yeah, you can find
Find
the
gamma.
cycle.
Yeah, we can find the last angle and then we will have a complete row. What does gamma have to be?
None.
95. Now we have a row with everything in it. What's the only downside to that last row, though?
It could be wrong.
It could be wrong. So you really, I mean, we are correct. You want to double check and make sure that you're right, because you're going to use that last row to find B, and you're going to use it to find A. So now if you made a mistake, everything's wrong. In terms of the order, you could do A or you can do B first. It doesn't matter. Anybody have a preference? What's your favorite letter? Out of A or B? A?
B.
What's wrong with B? All right, so let's solve for A. Okay, you can set up your template for your proportion. What trig function goes in the top of each one? Okay, you're always going to have sine of something, sine of something. Okay, what can I fill in for the one on the left? Sure, if we're going to find A, sine 45 over, what goes in the bottom?
A.
Yep. And what about on the right-hand side? Sine 95 over 4. Anybody tell me in one step, not as a decimal, but just as a fraction, what A will be? What times what divided by what? Yeah, Kate?
745 times 4 divided by 795.
Yes. The only thing I wrote a little different, I just switched the order that she said the first two things in. So that way there's no confusion that, if you write something like this, we're not sure, does that mean to do the sine of 180? Or to take the sine of 45 and multiply by 4 first? So I always just stick the number in front. But that's fine. Okay. And that's A. So I'll plug it in, see what we got. So we got 4 sine 45 divided by sine 95. 2.839. Now, can I use the Pythagorean theorem to get B?
No,
No? Why?
there's no hypotenuse.
Yeah. If you use the Pythagorean theorem, you're assuming you have a hypotenuse and you don't. So B would definitely come out wrong. Okay, our angle is close. It's 95, but it wouldn't come out right because it's not 90. Now on the test, if I give you a problem that has a 90, you can use the Pythagorean theorem. But this one you can't. Okay, so let's finish up and solve for B. What row are we definitely going to use again to find B? Yeah, we're definitely going to use row C again. It doesn't matter if you put it on the left or the right, it's the same thing. And what's going to go on the other side?
Sine 40.
Sine of 40 over B. Yep. Okay, somebody tell me what B will come out to? Maybe what? 4 times what?
Sine 40.
Yeah, 4 times sine 40 divided by, yeah. So if you can just pull up the last thing you typed in on your calculator, all you have to do is change one number. Change 45 to 40. we get 2.581. Okay, let's check and see smallest side with smallest angle. Let's check it all. 40 with the 2.5. Yep, that looks good. Alpha is just a little bit bigger than beta. So in this case, A should be just a little bit bigger than B. And it is, just a little bit bigger. Okay, any questions on angle, side angle? That's the second time. Nice. Let's move on to our third and final type. Side angle. What can't you do right away here that we were able to do on the last two?
Find the three.
Yeah, able to find that third angle. You can't do that here because you don't have 2 out of 3 angles. Okay, so this is a side angle. So what do we use in trig to solve for an angle? And we learned this last week. We haven't used it yet today, but we've used it before. Okay, this one is going to have a variable inside the trig function. So we have to cancel out the regular trig function with another function. Inverse. Okay, we're going to end up using inverse. But remember what happened when we used inverse? We had to have these domain restrictions so that way we didn't get 2 answers. Well, that kind of thing can happen here, except there could be 2 separate answers that both work. Okay? So anytime we use inverse sine, we always have to check for a second answer. Okay? There might not always be a second answer. There might only be 1 answer. In fact, there might be no answers. Okay, but when you solve a side angle problem, you can end up with 1 answer, 2 answers, or no answers. No answers are nice because you start solving the problem, you realize pretty quick you're done. You can't solve it. 1 answer, that's kind of normal case. And then 2 answers is a pain because it takes twice as long. It's not harder, but you have to solve 2 separate problems to get the answers. But the 2 problems that you solve are just like the ones you've been doing. You just have to do 2 of them. All right, so let's start to solve it. And when we get to the point where you need to check for the second answer, I'll explain, 1, how do you find what the second answer is? And 2, how do you know if it actually works? Okay, I'll show you both. So here's our table. A and B, and alpha. Okay, can we use Pythagorean theorem to get C? Nope, why not? Right, we don't know any of the angles. We don't have an angle here that's 90. Gamma could be 90. We don't know. We haven't solved it yet. But we can't assume it's 90. Let's set up our portion. This time you are somewhat forced to use 2 rows here. Okay, sometimes you have a choice about which one you solve for first. You don't have any choices in this problem. What is 1 row you definitely have to use? Yeah, you got to use row A. And what's the other row you have to use? B. Why can't you use row C? You're missing everything. If you try to use row C, you're going to have 2 unknowns. You can't solve it if there's 2 unknowns. You have to do it with just 1 at a time. So row 1, or row A, and row B. So we're going to have sine of 40 divided by 3 equals sine of beta over 2. What's different about where the variable is this time? Yeah, it's in the top. It's inside the sine function. So eventually we'll talk about how we get rid of sine. Okay, so we'll cross multiply. I'll do this one out the long way. So I get 2 sine 40 equals 3 sine beta. What would be my next step? There's at least one other thing that's easy to put on the other side. The 3. And how would you do that? Divide by 3. And 3. So now we've got 2 sine 40 over 3 equals sine beta. Okay, good. But now we want to get just beta. So what do I do to get rid of sine? Yep, I'm going to take the inverse sine. I'm going to plug everything on the right-hand side into inverse sine. And I'm going to do it on the left. I'm going to plug everything in the left-hand side into the inverse sine function. Okay, what that does on the right is it cancels out my trig functions. And I'm left with just beta. Okay, and what is beta? It's the inverse sine of 2 sine 40 divided by 3. So second inverse sine. And if you're going to type it in all at once, you have to put your parentheses pretty much like that. And we get 25.374. Okay, this is not a no solution problem. How do I know? I just got an answer, 25.374. If it was no solution, the calculator would have given me an error. Okay, and we've seen that before, but not this time. Okay, so we at least have one answer. Generally, what I do when I think there's the possibility of a second answer, which again is only in this case, first two types of problems we did today, you never have to do what we're going to do right now. It's just this case. I'll write the answer kind of in the top part of the box. And then if there ends up being 2, I'll call the first one beta 1. And I'll call the second one beta 2. If there's a second answer. And then if there's 2 answers for beta, that means the rest of this problem has 2 answers. C1, C2, gamma 1, gamma 2.
How do you know if there's 2 answers?
Well, that's what we're going to check right now. So now I'm going to show you how you get the second answer. Okay. We got the first answer. Any questions on 25.374? Okay. Now we're going to use that to check if there's another answer. Take what you just got for beta, or it could be alpha. It depends on what you don't know in the problem. Take the answer you just got and do 180 minus it. So let's do that. 180 minus, was it 25.374? Yeah. So if there's another answer, that's what it is. 154.626. Okay, let me write that down off to the side.
Where'd you get that?
So you take the answer that you just got and do 180 minus the answer we just got. So I did 180 minus 25.374.
That's like an answer.
If it works, that's the second answer.
Just work, right?
Well, let's check and see if that makes sense. We have to see if it's possible to take the angle that we just got, that 154, and the original angle they gave me in the problem that I know is correct, and see if they would fit in the same triangle. Okay, what was, and I'll scroll back down so you can write that down. But what was the given angle in this problem?
40.
We were given a 40. Is it possible to fit a 40 and a 154 in the same
Can you go
triangle?
back to that later?
Yep.
No,
Why not?
because it has to equal 180 now.
Yeah, it has to add up to 180, and these are, yeah, it's too big. If you take the second answer, which we didn't make a mistake, this would be the second answer if it worked. It's just in this problem, it doesn't work. The given angle they gave me was too big to start with. Okay? So, the second answer doesn't work. All right, so we did 180 minus what we had for beta. Okay, we did that out. We got 154.626. But the problem is you were given a 40-degree angle to start with. And if you add what you were given to the possible second answer, it adds up to more than 180. It's too big. Now, let's say the other answer came out, let's make it smaller, 110. Now we're good. Okay, you were given a 40. Could you fit a 40 and a 110 in the same triangle? Sure. Okay, so later we will do one, probably tomorrow, where the second answer is small enough that it works. Okay, but this answer was too big. Okay, any questions on how we found what the second answer could be and how we figured out it was too big? Both of those are important steps. Okay, does everybody have what they need? Yeah? All right, so now we can go back up and we can finish this problem just like a normal problem. Okay, so now we've got alpha, we've got beta, we've got 2 out of 3 angles. How can I get the third angle? Yeah, just add up what we got here, 65.374. Subtract it from 180. And that means gamma is 114.626 degrees. And now we can finish off by finding C, just like we did in the first two problems. What would be the best row to use to find C? Yep, you want to use A because everything was given, so we know it's right. So let's just do it over here. So we'll find C. So we're going to do sine of 40 over 3. And what will go on the other side if we're going to find C? Sine of what? So 114.626 divided by C. Now 114.626, that is rounded. Since we went to 3 decimal places, it shouldn't affect the accuracy of our final answer for C too much. It will affect it a little bit, but that's why I'm having you round to 3 decimal places. Okay, let's do that up. So C is going to be 3 sine 114.626 divided by sine 40. Anybody type that in and get a decimal? See what we got? Okay, we'll just type it in together. All right, so we got 3 sine 626. Make sure you put in 114. Divide by, and what did you get? 4.242. And did you round to that third place correctly?
3.
Okay, it goes up to 3. 4.243. And that's it. Okay, so when there's only one solution, it's actually not any worse than the other ones. But when there's two solutions, it takes a little longer.
What if there's no solution?
We feel that off there.
Again, this side-side angle, this is the only time that you have to check for two. You don't have to do this checking for two answers on any other case. What was the question about no solution?
Do you just not finish it if it doesn't have a solution?
Well, let me show you what would happen on a no solution. So you use your calculator and you try to type something in like this. Inverse sine of 17 over 12. You'd hit enter and it would say error. And the reason that's going to happen is because inverse sines, anyone remember the largest number that it could be? Think of the graph of sine and what's the highest that it goes? 1. Okay? Inverse sine can't go any higher than 1. And 17 over 22 is bigger than 1. Okay, so you'll know when there's no solution. And we're going to do one tomorrow.
So when it says no solution, you're supposed to-
Yeah, when there's no solution for one part, there's no solution for all the parts. Yep. But we'll do the two and no solution cases tomorrow. Okay, any other questions on that one? All right. So the homework is on 266. It's 9 to 13, 17 to 21, and 25, just the odds. Okay, just the odds.